Let's say university wants you to make a machine learning model and they want you to classify the application of the student, that whether they should give the admission to that student or not. And the classification will be based on two criteria. One is the test that then one is the entrance test that they're going to take. Okay, one is the entrance test that they're going to take. So let's say test, and other one is the grades at their college, okay, or school, grades at the school, and the entrance test that they want to take. So now these two are the criteria for, these two are the main criteria, or we can say column of the data set. We can say the two main criteria for a particular application that they can get rejected, or a particular application will get accepted for the university. Now let's say there is a student, okay, let's say there is a student who scored like let's say the student S1, who scored in the test, who scored pretty well in the test, which is 9 by 10. Okay, and his grades at the school were also very good, which was, let's say, 8 by 10. So according to our perspective, not our perspective, according to this data, according to this previous data, that student was accepted in the university. Okay, that student was purely accepted in the university without any problem. Okay, then let's say there's another student, okay, and his test scores were, let's say student 2, S2, his test scores was 3 by 10. Okay, and his grade at the school were 4 by 10. So according to the previous data, that student was rejected for the university. Okay, let's have another student, okay, which is S3, and this is another student, and I want to ask you one question. This S3 student scored 7 out of 10 in the test, and the grades at the school were 6 out of 10. According to you, what do you think, whether the students will get rejected or whether the student will get accepted? So basically, I want to know whether this S3 student, let's make him again, I want to know whether this S3 student, okay, who scored in the test, in the entrance test, which is 7 by 10, and in the grades, his grade at the school were 6 by 10, whether the student is going to be accepted in the university or not. Okay, we want to know that. So how the computer will do this? Let's see. So basically, let's have first of all, let's have, a two-dimensional graph. We are taking 2 dimensions for this criteria. We are having 2 criteria to decide this. So let's say we are having one criteria which is grades, and another one criteria which is, let's say, test. Okay, so let's type here. This one is y-axis, and this represents grade. Okay, and this one is x-axis, and this represent test scores. Simple. And according to the previous data, that means the data I'm talking about is this 9 by 10, 9 and 8. Okay, this 9 and 8, let's try to 9 and 8, let's try to plot this one. So let's plot him out. And let's say that this is the 9 by 8. Okay, let's say this is the 10. This one is 9. So 9 is the test here, and let's say this is the 10. Okay, let's remove this one for now. Let's remove this one, and this one is 9, let's say, and this one is 8. Okay, so 8, so 9, and this is going to be here somehow. Okay, this is going to be here, which is student S1 simply. Okay, let's make it to color blue only. Yeah, and for the student S2, whose grade were 3 and 4, let's plot him out. So this may be 3, this is 0, this is, let's say, 0 or 1, 2, 3. Ignore anything else, like, we have many things in between. Let's do it. Let's put it like this. Let's have 0, 2, 3 here. Okay, so this is going to be coming here. First of all, 3 for the 3, and his his for grade were 4, so let's say this one is 4. Okay, this one is 4 from 0 till 4. This one is 4, and let's say this particular student is coming here somehow. Okay, so according to the S1 student, according to the S2 student, this is going to be the graph. Okay, and now to decide whether the S3 student is going to get admission in this university or not, what we're going to do, we want to ask university that give me your previous records, all the previous records you have, and based on that I will be able to decide. Okay, my machine will always decide that whether the student should get rejected or whether the student should get accepted. Okay, so what will we do? Okay, let's take some random points like this. Okay, and let's quickly do that so that we don't waste any more time. We are having these random points somehow. Okay, these are some random points, not this one. Let's say this also, and then we have and then we have some rejected one. These were the accepted ones, with higher grades and higher grade and higher test score. And these are some rejected one, okay, which have been rejected due to their less scores. Okay, due to the less scores in their test and also their grades. Let me put quickly, include consider them as points for now. Okay, and now once we did that, now what we're going to do, we are going to make a machine learning model this time. Okay, what we're going to do, we are going to make a machine learning model this time. Okay, so to fit a particular line, let's take the another color. Just a second, we are going to take let's say blue color for now. Okay, and take the line. Now we want to decide whether a S3 student should get rejected or whether that S3 student should get accepted. And now our work is to make the model. So now our model does what our model does. It fit a exactly straight line between these two. It tries to fit a exact straight line between these two. Okay, it is trying to fix the straight line which can divide the whole data set into two parts. Okay, so there are some room of errors, like these red points are the errors, these green points are the errors which were wrongly classified, but this is the perfect fit line that separates the green part and also the red part. That means the accepted student and the rejected students. Simple. So according to this model fit, this is called our model. Let me just give you, this is what the whole machine learning engineers work, fitting a line. This is our model. Okay, now when we try to detect whether this S3 student should get rejected or he should get accepted, then what we'll be doing, we are going to plot him out. Okay, so we are going to plot him out. Let's say we take the, let's say blue color, and we try to plot him out, which is 7 and 6. So this one is 7, let's say this one is 7. Okay, and 3, 4, 5, 6. This one is, let's say this one is 6. So according to this, the student is lying here. Okay, the S3 student is lying here. And according to the S3 student, let me put it in the yellow so that you don't get confused here. Okay, the S3 student is lying here. Okay, according to the 7 and this 6, S3 student is lying here. That means according to their previous data and according to the learning of their previous data, the model is suggesting that this S3 student, which is having the test score as 7 by 10 and grade for the school as 6 by 10, should be accepted in their university. And if your answer was yes, you're good. Okay, so basically the answer was yes here. Okay, so now this whole process that we did here is called as logistic regression. And as we discussed in the linear regression class, that there is a proper way how logistic regression is going to fit a model, how logistic regression is going to build the algorithm to fit the model. And that we are going to talk about in the next lecture, that how this line is getting fit between these points, how this line gets fit between these 2 points, separating the whole data set into 2 parts, and then we are able to decide what we should do. Okay, and one more thing I want to tell you, there is a difference between linear regression and logistic regression. Although linear regression solves some kind of continuous data problem, in the last lecture we solved that what is the rate what is the rate of a particular house. That means that house is having some continuous value, right? A continuous value. So that value, when we are solving a continuous problem, when we are dealing with the continuous data, we'll be using linear regression for that. And when we'll be using the classification data, here we are not detecting any, here we are not predicting any kind of value. Here we are classifying it, whether they should give, whether I should give the whether the student should get the admission in the university or not. This is the classification problem. The work of the logistic regression is to classify the data, according to the previous data. And now in the next lecture, we are going to talk about how this model is made, and how this model helps us to to divide the data and form the have the minimum error between the data and the model. Okay, so we'll be talking about that in the next lecture. So let's meet in the next lecture. Thank you so much. We'll meet in the next lecture. To change your